Hello everyone, my name is Said Barghi. I'm an analytics solution architect at AWS, and today my colleague Praveen and I will talk about the features available in AWS Cloud for secure, cost-effective, and performant data sharing. We will review the benefits and challenges of data sharing, discuss some of the architecture patterns that enable sharing data products on AWS, and dive in to discuss the details of how data sharing works for Amazon S3 and Amazon Redshift, the two services that help our customers build a modern data architecture on AWS. We will also see a demo of the features and services we discussed today, and we will summarize the subjects we discussed at the end of the session. Let's start with the benefits of democratizing and sharing data. As organizations produce and store large amounts of data in their purpose-built data lakes and data warehouses on AWS, they are looking for mechanisms to be able to share their data internally and externally. That's because having access to broader data sets allows decision makers to navigate the ever-changing business world of today more efficiently. It gives them a better view of the ecosystem they operate in and enables them to make decisions based on more meaningful insights. As a result, organizations benefit from improved operational efficiency, innovate faster, and become more agile in running their businesses. To put the importance of data democratization in perspective, I want to mention something that Forbes published. They found that a typical Fortune 1000 company will see a $65 million increase in net income only by making 10% more data accessible. Now let's see some of the use cases enabled by data democratization. In healthcare and life sciences, data sharing enables discovery and manufacturing of new drugs when researchers are able to share their findings with each other securely, and therefore improves patient outcome. Organizations in education sector are able to create more engaging content when they collect feedback from different channels and use that to increase customer interactions. Being able to share data makes regulatory data collection easier for organizations in financial sector, such as central banks and financial regulators. And credit decisioning can be done faster and more accurately based on a more comprehensive data set that shows individuals' financial behavior. Commonwealth and state and territory governments are able to implement Intergovernmental Agreement on Data Sharing, or IGA, securely, cost-effectively, and in a shorter period of time. This framework helps with broader recognition of data as a shared national asset, and governments across Australia will be able to deliver more effective policies and services for Australians. And finally, utilities companies can work with expanded datasets to train their predictive maintenance models and therefore improve efficiency and workplace safety. To deliver the use cases we just saw, we commonly see our customers build a layered architecture for their data platform, which is comprised of services for data storage, data processing, and data consumption. Consumption layer at the top is centered around the various and diverse set of use cases that you want to deliver using your data platform. Some examples are BI reports, interactive queries, log analytics, or building AI and ML applications. And then in order to deliver those use cases, you need purpose-built tools and processing engines that are optimized to provide best price and performance. We see some of our customers prefer SQL-based ETL pipelines, and some others may choose big data processing frameworks such as Spark. In the next layer, we have a centralized data catalog, which provides a unified view of all your data assets. The unified catalog helps with consistent security and governance enforcement and facilitates data democratization. Next, we have a unified storage layer that is made up of data lake and data warehouse. This layer enables organizations to use different types of data, including structured, semi, and unstructured data, to run analytics. On AWS, there is a native integration between those two storage mechanisms that enables seamless access to all your data, no matter where it sits. In this session, we will be talking about sharing data from this layer. Finally, we have a number of ingestion tools to extract data from various source systems and bring them into the storage layer. And as the organizations build their cloud-based data platform on AWS and deliver the use cases we discussed earlier, they develop new data products that they want to share with others internally and externally. DJ Patil, the former United States Chief Data Scientist, defines a data product as a product that facilitates an end goal through the use of data. But traditionally, sharing data products was a challenging undertaking for many organizations due to a few reasons. The main contributor was the fact that up until recently, many organizations relied on ETL jobs to share data internally and externally. While ETL jobs play an important role in building a modern data architecture, skills required to build data pipelines are hard to master, and building data pipelines take considerable amount of time to develop, automate, test, and deploy. They are complex to maintain since changes in data sources require redevelop and retesting of existing pipelines, and as the data volumes increase, performance slows down, which means more investment is required in infrastructure that runs the ETL, as well as in licenses for third-party tools. And at the same time, maintaining security compliances is hard, since the data producer loses control over the data when it is moved over to the consumer environment. We at AWS listen to our customers and their challenges, and we realize our customers want better ways for sharing data in situ to improve the agility of the organization. And they want to be able to share data they have in their data warehouse as well as the data lake. To help our customers solve those problems and challenges, data sharing on AWS is based on a few key principles. Firstly, data should never have to be copied over for data sharing, since moving data incurs cost, slows down data accessibility, and results in silo teams. It should be possible to share as much data, for example, a whole database, or as little data, for example, only part of a table, with the consumer, and access is controlled at the granular level down to columns and rows. The consumer will pay for compute to query the shared data, and the storage cost is only incurred to the producer, since data is not copied across to the consumer environment. Also, producer and consumer are built separately for the resources they use. And finally, the sharer can decide to stop sharing the resources at any point in time. Now let's have a look at some of the architecture patterns that are enabled by no-movement data sharing on AWS. The first architecture pattern that I want to discuss today enables data as a service. It refers to sharing data as a service across different groups in the organization, and also with external parties outside the organizational boundaries. In this scenario, the producer acts as a destination for ETL or ELT jobs and stores data, and serves multiple BI and data science workloads sitting in different environments, and centrally controls what data is shared with which consumer. The next pattern helps with testing new features or changes to existing features of analytics workloads. With data sharing on AWS, developers and testers will always work with the latest data from the production environment without having to wait for the data copy to finish. And the last pattern I want to talk about refers to cross-group collaboration. With this pattern, our customers can seamlessly collaborate across business groups for broader analytics and data science in use cases such as cross-product impact and intra-agency collaboration when they are responding to major events such as the current pandemic. And in all these patterns, you can choose Amazon Redshift Serverless as the producer or the consumer of data. Amazon Redshift Serverless takes away the undifferentiated admin tasks and frees up resources to work on the tasks that add value to your business. And from cost optimization perspective, you can start small and Redshift scales up or down as the load on your cluster changes. Therefore, your Redshift cluster always uses the amount of resources it needs, and you don't have to provision infrastructure in advance to handle peak usage. Now let's change the gear a little bit and look into the services that build a modern data architecture on AWS and how they enable data sharing out of data lakes and data warehouses. We see many of our customers build data lakes on AWS since they provide the flexibility of storing data once and then analyzing it using the tools of choice. Data lakes allow you to build a unified repository for storing structured, semi-structured, and unstructured data at any scale. You can store data in open formats and then analyze it using purpose-built analytical tools and processing engines as it best fits your workload. To build data lakes, our customers have been using Amazon S3 since it is highly secure, durable, and performant object storage service. With Amazon S3, Organizations of all sizes and industries can store any amount of data for their use cases, such as delivering analytics application, archive, backup and restore, and disaster recovery. It is built upon 15 years of innovation, and it offers the lowest cost for storage for archival data. And so that you don't have to compromise between cost saving and speed of data retrieval, at reInvent 2021, we launched a new archival storage class called Amazon S3 Glacier Instant Retrieval. It delivers the lowest cost storage for long-lived data that is rarely accessed and requires millisecond retrieval when data is needed for analysis or compliance purposes. Now let's talk about the main challenges associated with sharing data and building products on data lakes. One of the main challenges is the complexity associated with sharing data between multiple accounts. We see most of our customers at a certain level of complexity have a multi-account data architecture. This could be for a variety of reasons, such as workload isolation, cost allocation, or permission governance. Now, in order to share data between AWS accounts, in the past, customers ended up creating multiple copies of data. And as we saw earlier, copying data as a sharing mechanism is not a scalable approach and might break your compliance policies. The second challenge is about access control when sharing data. What we have seen is, in order to set up fine-grained access control, customers used to create multiple copies of data by removing certain set of columns. Now, this solution could work with small number of resources and users. However, when the usage needs to scale to hundreds of tables and thousands of users, then it can become an operational nightmare to manage. And the third challenge is that on the one hand, you are trying to democratize access to data products and the assets in your organization. And on the other hand, you have to ensure that the access complies with your regulatory and governance requirements. You need to have the right controls in place, and you should be able to review the access as it is set up and be able to audit and monitor as the usage grows, ideally from a central interface. This is where AWS Lake Formation comes into the picture. AWS Lake Formation helps with building and securing data lakes in the cloud in days instead of months. And by using recently announced governed tables within Lake Formation, which support ACID transactions and time travel functionality, you can get consistent data views for all your users, and you can query historical data versions and audit change data. Lake Formation provides fine-grained access control for data stored in S3 and allows you to control the access down to the cell level. That means you can restrict access to sensitive information within a table without having to create multiple copies. It provides tag-based access control for scaling data access and data sharing. This feature is quite handy when you are dealing with thousands of tables and users, as usually seen in medium to large size organizations. When it comes to data discovery and accessibility, Lake Formation makes it easier to discover and share data with internal and external users. By using Lake Formation cross-account data sharing, organizations can share data in one AWS account with other accounts without having to move data. This helps eliminate data silos and enhances team collaboration through controlled sharing of data products. Lake Formation provides a one schema, share everywhere architecture through its centralized data catalog. It means after sharing a database or table, if you make any changes to the table schema, that will get reflected in all of the consumers. The result is that your shared schema is always consistent and up to date. And these features facilitate delivering the use cases we talked about earlier, such as discovery of the new drugs in healthcare by providing scientists with live and transactionally consistent view of the data, such as experiment results. I want to share a story about one of our customers that has used data sharing with Lake Formation to improve the quality of the personalized experiences and services they provide to their customers. JPMorgan Chase implemented a data mesh architecture using AWS Lake Formation and other services on AWS. Data mesh is a domain-driven distributed architecture pattern in which each domain creates, shares, or consumes data products through federated governance. They had over 450 petabytes of data with multiple data lakes and data warehouses across their lines of business, and they were looking to scale even further. They use AWS Lake Formation to establish the foundation of the data mesh, and by doing so, they were able to implement central governance and enabled easy sharing of data products between lines of business, using cross-account sharing and tag-based access control features. Next, Praveen will tell us about data sharing for data warehouses on AWS and demonstrate how you can share data from various AWS-based data storage across different accounts to build a 360 view of your customers.
Thank you, Saeed. We provide Amazon Redshift as our data warehousing service. Amazon Redshift is a fully managed petabyte-scale cloud data warehouse that accelerates your time to insights without having to configure and manage any underlying infrastructure. In reInvent 2020, we announced Amazon Redshift Data Sharing, which provides a simple and direct way to share data across Redshift clusters in the same account, different accounts, or in different regions. It enables secure, instant, and cost-effective way of sharing data products that provide transactionally consistent view of the data. Access to data products that is made up of database, schemas, tables, views, or user-defined functions can be controlled on the data producer and data consumer sides separately. Now let's take a look at how that happens under the hood. Data sharing on Redshift for both provisioned and serverless compute is enabled by Redshift Managed Storage. The architecture allows for separation of storage and compute and independent scaling of each component. Instances with managed storage use high-performance SSDs for the hot data and Redshift Managed Storage for the cold data. This provides cost-effective storage with faster query performance. Also, when using data sharing between clusters, the frequently accessed datasets are cached on the local compute nodes of the consumer cluster. This results in faster query performance for recurring workloads such as BI and reporting. For organizations wanting to share their data with third parties and monetize their data products, we introduced AWS Data Exchange for Amazon Redshift. In this case, access is automatically granted when a customer subscribes to your data and automatically revoked when their subscription ends. Invoices are automatically generated and payments are collected and dispersed through AWS. This feature empowers you to quickly query, analyze, and build applications with third-party data. I want to share two customer success stories related to Redshift data sharing. In case of Epsilon, they were able to achieve live data sharing with just few SQL statements. This eliminated the manual and time-consuming tasks they had to undertake previously, and it resulted in increased client satisfaction. And Warner Brothers was able to simplify their data stack by removing components responsible for data copying between Redshift clusters. This helped them become more data-driven and improved team collaboration. Now let's see a customer use case of data sharing in action. We are going to show you how to build a customer 360 use case with data sharing on data lake and data warehouse. So let's say there is a fictitious financial company called Annie Banking, who are a consumer banking service and provides mortgages and loans to their end users. The company has multiple line of business units who have their own environment, IT systems, and AWS accounts that they manage. Now the sales team on the right side wants to build a customer 360 view which would provide a unified and single view of the customer. They would like to understand the demographic distribution and source channels for their high-valued customers and accordingly optimize marketing spend and targeting efforts. In order to do that, they would like to source website data from the marketing team and the core finance data from the finance team. The marketing team uses a Amazon S3-based data lake to store and process all forms of data. And both finance and sales team have their own Redshift clusters for their end user reporting and analytics. So in the demo, we'll first show how marketing team can share data with the sales team using AWS Lake Formation cross-account sharing. And then next, we will show how the finance team can share data with the sales team using Redshift data sharing. And then finally, we'll show you a dashboard using Amazon QuickSight that connects to the Redshift cluster in sales account and brings all of this data together to provide a unified view of the customer. In the first section highlighted here, we'll provide access of data stored in the marketing account to the sales account through AWS Lake Formation. Let's switch to the demo. I'm in the marketing account. The database that I want to share is website_data. If I click on View Tables option, I can see these two tables that I want to share. In order to share the database and underlying tables, I'll select website_data database, and then I'm going to click on the grant option. On this page, I select external account option, and I'll enter the account number associated with the sales account, which in this case is the data consumer. Next, I will select describe option under the database permissions. I'll also select describe under grantable permission, and this is required because the administrator of the sales account needs to grant database access to the Redshift Spectrum role in their account, and I'll hit grant. The next step would be to grant access of all of the tables in this database to the sales account. So I'll repeat the previous step, but this time I'll select all tables option, and I'll include permissions that's relevant to the table grant. So I'll choose select and describe options, and I'm going to hit on grant. Now the marketing team has granted access of the data. However, for the database to show up in the sales account, the administrator will have to accept the grants using AWS Resource Access Manager. So I log into sales account next. On this page, I have two pending resource invitations which I need to accept. So I'll select the first record and click accept. And then I'm going to repeat this step for the second record as well. These two resource shares are related to database and tables that were shared earlier by the marketing account team. Once I accept the shares, the database will start showing up in the Lake Formation console within the sales account. Now the next step would be to create a resource link for this shared database. This is done to ensure there are no name conflicts when multiple teams are sharing resources with your account using the same name, and it also enables engines such as Spectrum and Athena to run queries on this database. So I'll enter a slightly different name for this resource link, which is website_data_ext, and I'll hit create. The next step is to give permission of this shared database to Redshift Spectrum role. So I'm going to select the database, choose grant, then select the Redshift Spectrum role, and then I will select describe under database permission, and then I'm going to hit grant. Next, I'll repeat this step for all tables within this database. So I select the record again, and then I'm going to pick the Redshift Spectrum role using this drop-down. But this time, I'll select the all tables option. Then next, I'll choose select and describe, and then we'll hit grant. One final step within Lake Formation would be to grant access of resource link to the Redshift Spectrum role. So I'll select the resource link. I'm going to choose grant, then select the Redshift Spectrum role using the drop-down, then select describe under database permission, and then I'm going to hit grant. We have now completed the cross-account data sharing from marketing account to sales account using AWS Lake Formation, and so the next would be to navigate to Redshift Query Editor in the sales account and create an external schema that points to the resource link created earlier. So I have a query written here to create the schema, and I'm going to select this query, and I'm going to hit run. The query has completed, so I'm going to refresh the schema explorer, and then this new external schema along with the two tables, GA and G_visitors, will start appearing. Next, I'll run a quick test on G_visitors table by running a simple select statement, and we can start seeing the results now. The query that is running in the Redshift cluster in the sales account is using Redshift Spectrum to access data in the marketing account. This completes the first section of the demo. In the next section, we will show how to share data between different Redshift clusters in the finance and sales account. To do that, I have logged into the finance account, and I'm connected to the Redshift cluster in this account using Query Editor. Next, I'll set up the data share using few SQL statements. The first statement creates a data share object called finance data share. Next, I'll add schema that I want to share, so I select the SQL statements and hit run. After that, I will include the list of tables that will be part of the data share. Once that's done, I need to give access of the data share to the sales account using cross-account sharing. So I'm going to execute this grant statement. From there, the finance account administrator needs to authorize the access of Redshift data share to the sales account. So I'm going to select the finance data share object and I'll click on authorize. I'll confirm the selection. In the next step, I log into the sales account as the administrator. Then I go to the Redshift data share page where I have option to associate the finance data share object to the entire sales account or specific clusters or regions. I'll choose the entire sales account for this demo. Then I log into query editor in the sales account and execute these two SQL statements. This will create an external database and an external schema that points to finance data share object. Once I hit refresh in the schema explorer, I'll start seeing the external finance database and schema. I'll do a quick test by selecting the sample table and then I'll start seeing the results. The data that you see here is from the finance Redshift cluster. This completes the second section of the demo, and next we'll build a quick site dashboard in the sales account, which I have done in advance. This quick site dashboard provides a unified view of the customer by combining data sets from sales, finance, and marketing accounts. All of the data is available through single Redshift cluster that sits within the sales account. At the top, you can see a few charts related to customer growth and trends. And then there are a few charts that provides demographics distribution. For example, this graph combines data from finance, customer, and website inquiry channel to give you an insight about campaign and marketing effectiveness. You can use this information to optimize marketing spend and improve customer experience. Now, when there is an update to the underlying data set in either the finance or marketing account, the user just needs to refresh the dashboard to see the latest data. This is all made possible by in-place data sharing. That's the end of the demo, and now let's move back to the presentation. In summary, we saw the benefits of data democratization with internal and external users. We also saw some of the architecture patterns enabled by no movement data sharing and talked about the main use cases they support across different industries. Also, we discussed how our customers are able to share data they have in their data lakes as well as data warehouses, and then looked into the mechanism available on AWS that help with access control for data producer and data consumers. If you would like to know more about the topics discussed today, please visit our case studies website and various blog posts we have published on this subject. To continue your cloud journey, we encourage you to use these training resources and also invite you to join the AWS Certified community, which brings together AWS Certified practitioners and builders in an exclusive online community. Thank you for your time today. We look forward to hearing the innovative ways you will be using data sharing on AWS. And please feel free to get in touch with our architecture team if there's something we could help with. Also, we really value your feedback that will help us improve our sessions. Thank you.